Hello, stats class. This is the notes for 4.3, which is pretty short and fits well on a Friday, so I thought that would make sense to do it that way. Just a quick reminder of the end of 4.2, we talked about the scope of inference, and I just wanted to mention that again, just so that you hear it more than once. Scope of inference means what kind of conclusions can we make, and if you do a random sample, you can generalize your results. You can generalize about the population that you took that sample from. And that was in lesson 4.1. When you do randomly assigned treatments, which is lesson 4.2, you can make conclusions about cause and effect. And one of the common problems or mistakes that people make is trying to do one when they should be doing the other. So like they might randomly assign treatments and try to say that what they did would work on the bigger population when really it only works on people like their volunteers. Or they'll take a random sample and they'll say, well, then this must be cause and effect because this happened with my sample, but they didn't randomly assign treatments. So be careful that you do the right one of these. Very rarely people will do both at the same time, and then you can make both types of conclusions. But that's not usually done in practice. Usually you choose which type of conclusion you want to make, and that's how you design your study. And then, of course, if you do neither, that's just plain wrong. You can't make any conclusions from that. So we had a little chart about that at the end of the notes from the other day that I wanted to remind you about. This is the wrong way. Can't make any valid conclusions. So a little bit of review about that. And then there's some challenges that I have not talked about yet, that things that could still go wrong even if you do it right. So let's talk about lesson 4.3 is mostly about the challenges involved in establishing causation. That's what I meant to say. And there's two basic things that I want to talk about, and the easiest way is to just give you examples of them and talk about them. So there's going to be more talking than writing in just a minute here. The first thing I want to talk about, and rather than tell you what this is called, which actually I'm not even sure what it's called, I'm just going to start with an example of a thing that's on cars called the Cyclops Light. And you may or may not have heard of this called that way. Cyclops, as you may or may not know, is a mythical Greek monster that has one eye. It's the same as a brake light in the center of the back of your car. And historical details here. It used to be that cars never had those. And so cars would have two brake lights, one on each side. And then somebody thought of this great idea that let's put a light in the middle because then people will notice that more. And the idea behind creating that Cyclops Light idea is that it would be more likely that the person behind you would notice you put on your brakes, which is the reason for brake lights in the first place. It should hopefully reduce rear-end collisions. That's what they were hoping would happen. And that's actually what did happen. When cars started having Cyclops lights at the beginning of this process, you ended up with 50% fewer rear ends for cars with the Cyclops lights. It's hard to say that fast, Cyclops Light. Anyway, cars with versus without. And the people who invented it were like thrilled because, oh my goodness, my invention worked. It's so much better. Cars that have this, they're getting so many fewer rear ends that it's just like the most wonderful thing ever. And so then they started putting it on lots and lots of cars because it was working so well. And several years later, they did their study again. And they found it was only 5% less rear ends for the cars that had the light versus without. And they're like, well, what happened? Why isn't it working as well as it did before? And it was just kind of confusing to people until somebody figured it out. And this is one of those ones where maybe it would be better to have done this notes live, because usually I ask the class, why do you think that happened? Why do you think several years later, the difference between with and without was so much different? And usually somebody thinks of it. What happened, and I'll just tell you this time, what happened was people got used to it. You know, drivers got used to seeing the car that had the extra brake light in the front or in the middle. And so it wasn't such a big deal. When it wasn't so common, it made a huge difference. But now that it's more common, it doesn't make such a huge difference anymore. So there's a confounding variable that they hadn't thought of that was causing this huge effect right here. The confounding variable was the newness or the unusualness versus the commonness of when it became common later. It made less of an impact on drivers. So that's a really fascinating thing. Any change you make is going to make a difference for a while, right? But then after a while, it's not going to make such a big difference. And I've seen this in other situations where, like in a factory, they tried different lighting to see if it makes people more productive or something. And sure, for a few days it would, because it's a change and it kind of wakes people up. But then after a while, they get used to it, and then it's not such a big change anymore. So that's one of the challenges in establishing causation. Yes, maybe the center brake light causes fewer rear end collisions, or maybe it was just the doing something new in general. And so nowadays I start seeing cars that have all kinds of weird lights. You know, maybe they go all the way around the outside of the car window or something. You know, they do weird stuff to try and get the driver's attention behind them. And that may or may not work. It works mostly if people are not used to seeing it. So that's one of the challenges that I wanted to talk about, is that anything new is going to make a difference, but then it might not keep making a difference. The second challenge that I want to talk about is ethical and practical issues. And this is mostly common sense. When you do the homework, you'll notice that most of the answers in the homework, maybe you could have answered before you even took this class, because a lot of it's just common sense. But let's just think about one big example of ethicalness of experiments. Here's a research question that scientists have been trying to answer for years. Does smoking cause cancer? And if we were in class, I would ask you to raise your hand and say, do you believe that smoking causes cancer? I do, but I will tell you, let's think about how you would prove this. If you are trying to prove cause and effect, I mentioned this the other day when we saw the Alzheimer's example. If you were to do an experiment to try and prove this fact that smoking causes cancer, you would have to randomly assign people to smoke or not to smoke. You'd have to force them. I don't know who would volunteer for that, honestly. And then you'd have to force them to do that for a long time, because probably a long time would be better, because it might take them a while to get cancer, right? And then you'd have to wait a long time for results. And these people in the study, I hope that you would tell them what was going on, but they'd be waiting to see if they get this life-threatening disease or not. See if they die or see if they get cancer. That just sounds really bad. So first of all, it'd be hard to find people to volunteer. Second of all, even if you could find people that would volunteer, it's not very ethical to give them a treatment that you think is going to kill them. That is not a good idea. And most governments would make it illegal to do that. In fact, they do. So it's not ethical and it's not legal to do this. But scientists and doctors and all of those people are still pretty sure that smoking does cause cancer. So once again, if we were in class, I would be asking you to tell me, how could they tell without doing an experiment? There are a lot of things out there that cause cancer, and there are a lot of things out there that cause bad things to happen to people. And medical professionals or researchers really do have other ways besides experiments. And so that's an interesting question. How in the world could they tell? So now some of this is still marginally ethical, of course, but one of the things they do is they do experiments with animals. And that might bother some people, I know. Let's choose an animal that nobody likes, right? And give them cigarette smoke to inhale all the time and see if they die from cancer or see if they get cancer. They do that, and it does actually cause cancer in animals. And I'm not going to go into the ethics behind that, but that's not as bad as experimenting on people. There's also some other things. There is, I would call it, overwhelming observational evidence. Autopsies on people who have died from cancer, and the ones who smoked, their lungs look terrible, and you may have seen some of that in health class or something, and the ones who didn't smoke, their lungs don't look so bad. Just overwhelming observational evidence. Huge numbers of people who smoke get cancer, and huge numbers of people who don't smoke don't get cancer, so that causes a very strong association. All of this is evidence without having to randomly assign treatments. The type of cancer makes a difference. Lung cancer is more common in smokers. Cancer of the mouth and throat is more common in people who chew tobacco. And so the fact that the cancer happens in the part of the body that is near where the tobacco was causes that. It's very consistent and replicable. You could do it again on different animals and it would happen the same way. The amount of smoking makes a difference. People who smoke more tend to get more cancer, are more likely to get cancer than people who smoke less. So that is another piece of evidence. The time involved as far as how long did you smoke, and also the fact that the smoking came before the cancer. So scientists use all of this as evidence, and some statisticians used to argue really strongly that because we can't prove it with an experiment, that we can't prove that smoking causes cancer. In fact, some of the famous people who argued that argument were ones that like to smoke. And that's like, oh gosh, you can't believe them. But they would argue that because we can't prove it with an experiment, that it's not true. But there's so much evidence in these other areas that doctors are really pretty sure that it's true. So don't smoke, kids. I just have to tell you this. Just don't. It's bad for your body in many different ways, including causing cancer. And, don't listen to these people who say it's not an experiment. There are ways to find things out besides doing experiments. And so there's some challenges out there that I wanted you to be aware of. That's what lesson 4.3 is about. As you can see, it's a really short lesson. There's not a 4.3 A and B and so forth. It's just 4.3. And that was it. It was just think about the common sense, practical background behind some of this stuff. Just so you know, Monday we will review and then we'll take the quiz. So I have a little bit more I want to do with, there'll be a bit of review notes and the review warm up on Monday before we take the quiz. But you should be getting ready for the quiz. And you have a choice this weekend of doing the 4.3 homework or doing the review homework. I don't care which one you do first. The other one can get put off till Monday, and then we'll take the quiz. So I will see you on Monday.